Welcome to the deep dive. Today, we're tackling a really core question in AI. How do we give these systems a memory?
Yeah, it's fundamental.
You've shared a fantastic set of materials all about AI agent memory, and, well, our plan is to unpack it all, cut through the jargon, see how things have evolved.
And really pinpoint what's crucial for you to grasp.
Exactly.
We've got quite a mix here. Some deep academic papers, like the one on MinAA.
Oh, yeah, the production-ready agent one.
That's it. And another on cognitive architectures for language agents. Plus a Reddit discussion, which is always interesting to see what people are actually struggling with.
Right, the practical side.
Blog posts, too. Decoding ML, talking about memory as the secret sauce.
I like that one.
Unite.ai on Meta's scalable memory layers. DigitalOcean explaining R, and Agentic Rag.
Lots on reg.
Definitely.
Yeah.
And even Redis announcing how they're working with Memzir. So a really broad perspective.
Absolutely. And this matters, right? Whether you're, prepping for a meeting on AI stuff or just trying to get a handle on agents specifically.
Or maybe you're just super curious.
That too. Understanding how AI agents remember or try to remember is key. It's how we get to more coherent AI, more personalized, smarter, ultimately.
Oh, so we'll try and navigate all that, give you those aha moments without getting bogged down.
Let's do it. So, first things first. Why do AI agents even need memory? What's the basic problem we're solving?
Well, that's the starting point, isn't it? Several sources, particularly the Mablor paper, point out that LLMs, while amazing at generating text,
They are pretty amazing.
they have this built-in limitation, the context window. It's finite.
Right. They can only see or remember the most recent part of the conversation.
Exactly. Which, as the Mablor paper says, makes it hard to keep things consistent over a longer chat. They just forget what happened earlier.
Like talking to someone who forgets the start of the sentence by the time they reach the end. Exaggerating, but.
Kind of. And the cognitive architectures paper adds another layer. It notes that early AI agents just picked an action based on what was right in front of them.
Simple stimulus response.
Pretty much. But newer agents, they're trying to do more. Reasoning, planning, and that needs memory. Especially long-term memory, to make better decisions over time.
So it's not just about holding on to the last few messages. It's about building a persistent understanding.
Precisely. But that same cognitive architectures paper flags a problem.
Oh, what's that?
Just the language we use. There's no standard vocabulary for describing what's happening inside these agents, how they plan, how they use tools, how memory works.
Everyone's using different terms for maybe the same idea.
Kind of, yeah. Which makes it tough to compare different agent designs or build on each other's work effectively. It's a real practical hurdle.
Okay, that makes sense. Hard to build solid foundations if everyone's using different blueprints, so to speak. So we need memory to get past context limits, enable planning. Now let's talk types. Short-term versus long-term seems to be the big split.
Yeah, the Decoding ML blog post breaks this down nicely. Short-term, or working memory, is about keeping track of the current conversation, holding the immediate context.
Like our own mental scratch pad.
Right.
What we're actively thinking about.
Exactly that. They use LangGraph as an example. It uses something called a state for this.
A state.
Yeah, think of it as a container. It holds stuff that doesn't change much, like maybe the agent's core personality or settings.
Static stuff.
Right. And also dynamic stuff, like the actual messages flying back and forth, maybe summaries of what's been said, info pulled from long-term memory.
Okay. And this state, this short-term memory, it doesn't just vanish when the conversation pauses.
Good point.
Yeah.
No, ideally it doesn't have to. The Decoding ML post stresses persisting this state, saving it somewhere, often a database like MongoDB.
Ah, so you can pick up later.
Exactly. You close the chat, come back tomorrow, and the agent remembers where you left off. That persistence is key for, a continuous feel.
Makes it feel less like a tool and more like, something you're interacting with over time.
Right. And the other big benefit of saving that state is handling multiple users. Each user gets their own thread, their own memory state, so conversations don't get mixed up.
Crucial for scaling. You can't have my astrophysics chat bleeding into someone else's recipe request.
Definitely not. Chaos.
Yeah.
So that's short term. But for the really persistent knowledge, the long-term stuff, RAG keeps coming up. Retrieval augmented generation.
Yeah, it seems central. What's the core idea behind RAG? Why is it so important for long-term memory?
So RAG, as Decoding ML, the DigitalOcean piece, and others explain, tackles that other big LLM limit. They mostly know what they were trained on, and that knowledge gets stale.
Right, they don't automatically learn new things post-training.
Exactly. ARGRA lets the agent cheat, Kind of.
Yeah.
It allows it to look up relevant information from external knowledge sources before it answers you.
Okay, so it's like giving the AI access to a library it can consult on the fly.
Perfect analogy. And the Decoding ML post lays out the two phases, ingestion and retrieval.
Ingestion. Sounds like feeding it the library books.
Pretty much. You take your documents, your knowledge base, whatever it is, clean it up, chop it into smaller pieces, maybe remove duplicates.
Standard data prep.
Yeah. Then the crucial step, you turn those text chunks into numerical vectors, embeddings.
The magic numbers that capture meaning.
Right. And you load these embeddings into a special database, a vector database, that's super fast at finding similar vectors. That whole process is ingestion, usually done offline.
Okay, so the library is indexed and ready. Then what happens when I ask a question?
That's the retrieval phase. Your question also gets turned into an embedding using the same method. Then the system searches the vector database for the document chunks whose embeddings are closest, most similar to your question's embedding.
Finds the most relevant passages in the library.
Exactly. Those relevant chunks are pulled out and given to the LLM along with your original question as extra context.
Ah, so the LLM isn't just working off its internal knowledge plus the immediate chat history. It now also has these relevant snippets from the external knowledge base.
Precisely. It augments the generation with retrieved information. Hence the name.
Retrieval augmented generation makes sense.
And that Decoding ML post mentions MongoDB being good for this because it can handle the messy, unstructured data and do both text and vector search in one place. Less complex infrastructure.
Always a plus. Now, there's also agentic RAG. How does that level things up?
Good question. The DigitalOcean article explains agentic RAG as combining RAG's fact-finding ability with the planning and, well, agency of AI agents.
So it's more than just a one-shot lookup.
Exactly. Think of standard RAG as the agent asking the library for info once per question. With agentic RAG, the agent is smarter. It might decide it needs more info, or it needs to ask a different question to the library, maybe multiple times within one turn.
Ah, so it can iterate, like, that snippet wasn't quite enough, let me refine my search and look again.
Yes. The Decoding ML post frames it as the egg retriever being a tool the agent can choose to use, potentially multiple times, to gather enough context before acting or responding. It integrates the retrieval more deeply into the agent's own thought process.
That sounds much more powerful, more like actual research. Okay, so RAG and agentic RAG are big players. But they're not the only game in town for memory, right? What other architectures are out there?
Definitely not the only ones. We saw mentions of memory networks, scalable memory layers, and Mem-Zero. Each takes a bit of a different approach.
Let's start with memory networks. What's the key idea there?
The end-to-end memory networks paper describes them as neural nets with basically an external memory block they can read from and write to using an attention mechanism.
Attention like in Transformers.
Similar concept, yeah. Guiding where the network looks in the memory. A key thing was making them trainable end-to-end, needing less explicit hand-holding than older memory models.
More automated learning of how to use the memory.
Right, and they introduced this idea of hops, multiple passes over the memory, like read something, think about it, read something else based on that thought.
Rereading and cross-referencing in its external brain.
Kind of. They found multiple hops were really important for performance on things like question answering.
Interesting. Okay, what about scalable memory layers, SMLs? From Meta AI, Unite.ai covered those.
The big idea with SMLs is decoupling the knowledge from the model's main parameters instead of trying to bake everything into the LLM weights.
Which makes the model huge and hard to update.
Exactly. SMLs use an external memory system, like a massive learnable key value store.
Like a database optimized for AI?
Sort of. The potential wins are smaller core models, easier scaling to huge knowledge bases, and crucially, you can update the knowledge in the external memory without retraining the whole LLM.
That's huge. Updating knowledge without a multi-million-dollar retraining run sounds very appealing.
It really is. They designed it to work efficiently on GPUs with parallel lookups.
Makes sense. And then there's Mem-Zero. It got its own paper and the Redis tie-in. What's special about Mem-Zero?
Mem pitches itself as a memory-centric architecture. It focuses on dynamically pulling out key info from conversations, consolidating it, and retrieving it smartly.
More focused on the conversation itself, maybe.
Seems like it. They talk about an enhanced graph-based version, too, for mapping out complex relationships within a dialogue.
Like who said what about whom and how topics connect.
Potentially, yeah. And the performance claims in the paper are pretty strong. They tested it on a benchmark called Locomo.
Oh, come on.
Yeah, it tests long context models.
Yeah.
Anyway, they found MEMSL significantly boosted accuracy compared to just feeding the whole history, or standard RAG, even some proprietary models.
Wow. And how did it manage that?
The suggestion is its dynamic processing and structuring of the conversation, maybe especially that graph part, lets it find and use relevant past info better. Plus, they claim it does this with less computational cost, fewer tokens, lower latency than just stuffing the whole chat into the context window.
Better accuracy and more efficient. That sounds like the holy grail.
It's definitely promising. And the Redis partnership makes sense, using Redis's speed and vector search for the underlying memory store. It feels like a step towards memory that actively learns from the conversation, not just retrieves external facts.
Very interesting. Okay, shifting gears slightly. That Reddit thread on memory management. What are the folks actually building this stuff running into? What's the view from the trenches?
Oh, it's clear it's a major headache. People are grappling with basics like, how do you manage the session state if a user interacts over multiple days? How do you keep different user threads separate?
The practical plumbing.
Totally.
Yeah.
And there's a real sense that the tooling isn't quite there yet. People are looking for good standard libraries to handle this stuff, but it feels a bit like the Wild West still.
So, lots of home-rolled solutions.
Seems like it. One user, Propagalic, mentioned using Postgres, a relational database, but setting up different tables for different kinds of memory.
Oh, interesting. Not just a vector DB.
Right. They had short-term history in one table, vectorized stuff for similarity search in another, and maybe structured long-term facts in a third. It shows you need different tools for different memory jobs.
That makes sense. You wouldn't use a hammer for every task.
Exactly. And another user, Yaltaputal, raised deeper questions like, okay, we store stuff long-term, but what should we store? And how do we update it if we learn something new that contradicts the old stuff?
Yeah, managing consistency and updates in long-term memory seems really hard. You don't want the AI confidently stating outdated facts.
It's a huge challenge. People mentioned exploring various tools. Menzil came up again, also Letta, which is related to MemGPT, LangChain, Agentas. Each seems to have its pros and cons for usability, scale, control.
Lots of options, but maybe no single perfect answer yet.
Feels that way. One user, Swoodley, had a useful distinction. RA is like level 1 memory, pulling external facts.
Yeah.
But managing the conversation context itself, user details, summaries, that's level 2.
A layered view. I like that. Helps organize the problem. So the community is definitely experimenting, struggling, sharing, but it's still very much an active development area.
Very active.
Okay, let's circle back to that cognitive architectures paper. It drew this parallel between modern language agents and older AI ideas. Can you unpack that a bit more?
Sure. So back in the day, AI researchers tried to build these holistic models of mind called cognitive architectures. Think SOR or ACTR, if those names ring a bell.
Vaguely. They aimed to model perception, memory, decision-making all together.
Right. And many use production systems, basically. Sets of if-then rules. If you see this condition, then take this action.
Okay, rule-based AI.
Yeah. And the paper makes this interesting link. LLMs, in a way, are like massive probabilistic production systems. They don't have explicit rules, but they define probabilities over what text comes next, which is like deciding the next action or symbol.
Huh. So even though the tech is totally different neural nets versus symbolic rules, maybe some of the control ideas from those old architectures could be useful.
That's the suggestion. How did those systems manage focus? How did they decide which rules fired? How did they manage their working memory? Maybe some of those control mechanisms, those patterns, could inspire ways to make today's language agents more reliable, less prone to just hallucinating or going off track.
Fascinating. Learning from the past, even when the underlying engine has changed completely.
Exactly. The paper also brings up some key future challenges based on this thinking, like defining the boundary between the agent's internal memory and the external world.
What's in the agent's head versus what's out there?
Kind of. They suggest criteria like controllability. Can the agent change the information? If it's a read-only database, it's clearly external. If it's a knowledge base the agent can modify, maybe it's more like part of its internal state.
That distinction matters for learning, I guess.
Yeah. And they also stress balancing the agent's action space, what it can do. More actions mean more flexibility, but also more risk and harder decision-making. Safety becomes a big concern.
Definitely. Especially as agents get more autonomy.
And looking ahead, the paper says a key research area is just improving the decision-making itself, making agents less overconfident, better aligned with what we want, better at handling uncertainty.
Not just retrieving info, but reasoning soundly about it.
Right. And they mention this exciting idea of memory-augmented agents that can write to their own memory, not just read external stuff. That could be a path to real lifelong learning, where the agent learns from its experiences and updates its own knowledge base efficiently.
Wow, that feels like a big step towards more adaptable AI.
It really does. It's
Yeah.
about using memory, not just for recall, but for genuine learning and self-improvement.
This has been really insightful. We've gone from the basic need for memory because LLMs forget,
To the rise of RAG for external knowledge.
explored these newer architectures like SMLs and Mem0,
Heard the practical challenges from developers on Reddit.
and even connected it back to older ideas from cognitive science. It's a complex landscape.
It really is. Constantly moving, too.
So if we had to boil it down, what are the absolute key things you think someone listening should take away from all this?
Okay. First, understand that short-term working memory and long-term memory are different beasts in AI, and both are vital. Second, RAG is currently a dominant, powerful way to give agents access to external knowledge, but it has variations like agentic RAG. Third, keep an eye on newer architectures like SMLs or MemOff. They're trying to integrate memory more deeply or efficiently. And fourth, maybe, just appreciate that this is still hard. Managing memory effectively, especially updates and consistency, is a major ongoing challenge.
That's a great summary. It highlights the core concepts and the ongoing evolution.
Yeah.
Maybe a final thought for everyone listening, something to chew on.
Okay.
As these AI agents get better and better at remembering us, remembering context, remembering facts, how does that change how we feel about interacting with them? Will they start to feel less like tools and more like partners, companions even, able to build on shared history in a way that feels genuinely, well, personal and intelligent?
Yeah, it's a deep one. Where's that line blur?
Yeah,
Definitely something to think about. Of course, this dive just scratched the surface.
for sure.
We really encourage you to check out the links to the papers and discussions if you want to go deeper. What bits got your interest the most? Let us know. We're always curious.
Absolutely. Thanks for joining us on the deep dive.